This is experiment 3 of physics. You will find experiment 3 on page 79 of your physics textbook and workbook. The aim of experiment 3 is to determine the magnitude of the velocity of an object that falls freely. Our investigative question will be, how will a free-falling object accelerate for time intervals that increase constantly? Our hypothesis is, a free-falling object will constantly accelerate downwards for time intervals that increase constantly. And now for the variables. The independent variable, which is changed, is the time interval. The dependent variable, which is measured, is the displacement of the interval. And the controlled variables, which remain the same, are the mass, gravitational force, period of the ticker timer, friction, and air resistance. The apparatus you are going to need to do this experiment are as follows: a ticker timer, a measuring stick, a stopwatch, and a mass piece.
The method of this experiment is as follows. Clamp the ticker timer to the side of the laboratory bench. Hold on to the mass piece and the tape and switch on the ticker timer. Drop the weight. Take care not to throw it. Process and interpret the ticker timer tape and complete the table. For the first space, the distance is 0,002 meters. The time is 0,02 seconds. Using the formula V is equal to delta D over delta T, that would be equal to 0,002 divided by 0,02, and that is equal to 0,1 meters per second. Complete the rest of the table on your own, using the spaces on your ticker tape. Use your results and draw a displacement time and a velocity time graph. By calculating the gradient of the velocity time graph, you are able to determine the acceleration due to gravitation.
There is still upward air resistance. The acceleration is therefore less than 9,8 meter per second per second.